All right, everyone, let's start the class. Okay, last class we talked about data mining, right? So we say once we have the big data, then we want to dig some useful information from the raw data, right? Then we say uh, we first need to get some information, general information about each predictor or each variable. Then this process is called the descriptive analytics, right? So for example, I want to know whether this variable has any outliers, right? Whether this variable has any missing values, right? For example, I want to know the mean of this variable, the standard deviation of this variable, right? The median, the range, IQR, right? So all of these are to describe each predictor, each variable, right? Then we call this process is to do the descriptive analytics. And then once we got some information about each predictor, then we can, for example, we can go through the regression, right? And then we can compute any hypothesis test, right? Get some confidence interval. So all of these ones are about the data mining. Right, so and then once we get the results, we will get some knowledge about the whole phenomena. And then based on this knowledge or based on your results, you can make your decision, right? So through the business marketing analytics. All right, and then we say the summarizing the large data is not the data mining, right? So summarize the large data is the descriptive analytics, right? And then last class, we also talked about these two types of modeling methods, right? So depending on what is your goal of your analysis. So for example, for the explanatory modeling method, right? So you will more focus on determining the relationship between X and Y, right? So for example, I get the relationship between the X and Y so that I know when the X increases, how the Y will increase or decrease, right? And then the other way, I don't care the relationship between X and Y. I just want to make the prediction. I even don't need this equation. I don't want to know this equation. I don't need to know these coefficients, right? What I need to know or what I need to do is just to make the prediction for each or just one observation as accurate as possible, right? Then we say for the explanatory modeling, then we can only do the regression so that we have this equation so that we can explain or interpret these coefficients, right? But the other way for the predictive modeling, there are many ways, right? So in the last class, we talked about the decision tree, right? So we say in this example, right, about the house price, right? So we say the total value will be our response variable, right? And since the text has the repeat information with the total value, then we do not include this variable into our analysis. Then all of the other ones, it doesn't matter you have the continuous random variable or, for example, the remodel, which is the categorical variable. Right, so it doesn't matter what kind of variable you have, you can all consider them as the explanatory variables, right? In the end, the decision tree can just produce a picture that is very straightforward for us to find which subgroup our observation belongs to, right? In the end, just use the mean of that subgroup to estimate the house price. Right, so for example, in this one, if we use this decision tree, then for this house, right, so that means the gross area is 4,000 square feet and the number of floors is 2, right? Then we need to read the decision tree from the top to the bottom, right? That means what? That means first you need to decide it is in this group or in this group, right? So in this case, 4,000 square feet will fall in this group, right? So that means there is no more subgroups for the number of floors. So the estimation for this kind of house will be just 542,038, right? It is in thousands of dollars. So then that will be the estimated value for this house. All right, and then we say if we keep splitting the data set, right, then we will have a larger decision tree. That means they will be splitted in more details, right? So let's say if we still want to estimate or make the prediction about the house price with 4,000 square feet and 2 floors, right? So if you have a larger or more detailed decision tree, again, we need to read the decision tree from the top to the bottom, right? So then first step, you need to decide which group it is, right? So that will be within this group, right? And then next, you have more subgroups after this this group. That means what? That means we need to follow here because 4,000 is less than 4,999, right? And then go to the next step, 2 more subgroups again, right? So that means we'll be in this group, which is less than 4104. And then 1 more step for 2 more subgroups, right? So since the number of floors is 2, so that will be falls in this subgroup, right? That means this house has the price which is 492,030, right? So that means if you have a larger decision tree, then your prediction will be more accurate. All right, so today we will just go through a example, right, and then talk about more details of the decision tree. All right, so now I want you to go to the module 6 page. All right, and then in the module 6 page, download this house, the housing data, right? So just download this data set, right? And then open it in the JMP. If possible, I need you to turn on your cameras so that I know your reactions, whether you can follow me well. Thank you, Gavin. Anyone else? Perfect. All right. So once you open this data file, right, data set, so actually the first thing you need to do is to look through these variables in the left list, right? So actually you see that you have the first one, which is the total value, right, which is our response variable y, right? And then you have the tax, which is the total value times the tax rate, right? So we say this variable has the repeated information with the total value. Then we should not include this variable into our analysis. So what we can do, we choose this variable, right? And then go to the columns in the top menu, right? And then exclude it from our analysis. You see this option? All right, so once you click this exclude, you will see that the text, this column is still there in our data analysis, but in the left list, there is a sign for text. That means this variable will be excluded from our analysis. So for example, if I do the analyze and distribution, you will see that in the left list of this screen, the text will not show up again. That means if you want to analyze analyze this data set, the text will not be in the list. All right, so this is the first thing you need to do. Another thing is you need to look at these variables, right? So first of these variables are all quantitative variables. So they will show the sign, which is a blue triangle there. So actually it is the blue histogram, but it's just looks like a triangle. All right, and then for the last variable, which is this remodel, if you look at this predictor, you will see that this variable is a categorical variable, right? And then it will show you a bar chart, which is a red bar chart there, showing you this variable is considered as a categorical variable in default. All right, and then these two, you don't need to care about these two yet. All right, so these two columns are the ones I just added to this data set. All right, so now we want to generate a decision tree. So we go to Analyze, right? And then before the decision tree, we want to learn something about each variable. We say we need to go through the descriptive analytics, right? So then we go to distribution so that we can talk about or learn something about all of our variables. So just to choose all of our variables and then choose goes to the Y except the last two. Right, and then click OK. Do you have this output? Right, so actually this is the way how you generate the summary statistics for each predictor at just one time. All right, okay, now let's just look at the first one as an example. For the total value, which is our response variable, you get what? You get a histogram, right? From the histogram, you know what is this distribution, whether there is any outliers. For example, the year built, there is one outlier here, right? Very obvious outlier here, right? And then we say, for the summary statistics table, it's defaultly it will show the mean, standard deviation, standard error, and confidence interval for the mean and the number of observations in this variable. All right, then if you need more information about this variable, right, more summary about this variable, you can click this red triangle beside the summary statistics. Right? And then there is one option to customize the summary statistics. Click that. All right. Then in this list is all the summary statistics you can get based on or for this variable. Right, so default will be these 6, but actually you can get, for example, the sum of all the observations of the total value, the variation, the variance, for example, the number of missing values, right? And then we say, for example, the minimal, the maximal, the median, the mode, the range, the IQR, right? So actually you should be very familiar with these ones, right? And then, for example, if I choose the number of missing, that means what? That means there is no missing value for this variable. All right, okay, so that will be our first step. We want to learn something about each predictor so that we can get a general idea. So we say for the first, these variables are all quantitative so that you say you have the summary statistics, you can calculate the mean of each variable. But the last one, remember for the remodel, it is a categorical variable. Right? In the end, in default, we say for the categorical variable, of course, you can not find the mean of it, the standard deviation of it, right? So actually, instead, you will have a bar chart with their corresponding frequencies. How many of them are non-remodeled? How many of them are new, are recent remodeled? How many of them are old remodeled? And then you have the total number of observations. And in default, it will tell you how many missing values in this variable. All right, okay, so now we are done with the first step, which is the descriptive analytics. Right, so now we can close this output, and then let's continue to generate the decision tree. Right, so we say we go to analyze. All right, and then we do not use fit y by x or fit the model. We need to go to the predictive modeling, right? We only care about the predictions, right? And then in this option, choose the partition. We are dividing or splitting the whole data set into different groups. So we are doing partition, right, to get the decision tree. Click that. All right, so now it's our time to choose our response variable, which is total value, right? And then in the last class, we used a simple example, right? So we say we use the gross area and the number of floors, just to consider these two predictors, right, first, right? And then click OK. All right, so again, this is the default output, right? So you have all of these black points showing you all the house prices, right, for each observation. And then here, it will defaultly show you a summary. But since you haven't started your splitting, right, so you don't have any information about your R square or MSE or anything else, right? So your number of splits for now is 0. Now, if you split one time, your number of splits will change to 1, and then you have your corresponding R square and MSE. All right, and then split twice, another time. Your number of splits will change to 2, tell you you have split it for 2 times. And then both of these 2 times are based on the gross area, right? Okay, and then if you split this third time, now, of course, the number of splits will change to 3, but now you have 2 more subgroups. Actually, these two subgroups are based on the number of floors. All right, okay, now if you keep splitting, let's say split it for totally 10 times. Of course, you will have a much larger decision tree, right? So you will get a more detailed decision tree. And then in the summary table, you see that the R square keep increasing, right? So change from 0.4 something and increase to 0.68. It is match with what we learned before, right? So if we keep splitting, that means in our regression idea that will be keep adding different variables, right? Then the R square will keep increasing. All right. Okay, so now we see that some of the splits are based on the gross area, some of them are based on the floor, and then after the floor, you can still split based on the gross area again. All right, and then we can go to the red triangle beside the partition. All right, and then there is one option called the column contributions. You see that? The column contributions. All right, so click that. You will have a one more table after the decision tree. Right, it will tell you what? It will tell you in this decision tree, you totally have 10 splits. 8 of them are because of the gross area. 2 of them are because of the number of floors. So how much contribution of this gross area predictor? 89.24% is contributed to the model or the decision tree. All right, and then 10%, 10.76% of the contribution is because of the number of floors. right? And also in this red triangle, the first option tell you the display options. All right, so this option tell you what will be shown in your output. Right, so sometimes I still cannot figure out why sometimes the show tree in default doesn't show up. Then what you need to do is to go to this right triangle display options and then choose to show the tree. All right, okay. So then let's close this output. All right, let's try something different. All right, so we say we still want to make this decision tree, but in this time, we still use the partition, right? Analyze, predictive modeling, and partition, right? But this time, I do not want to just focus on these two variables. I want to include all the predictors into my decision tree. Right, so similarly, you can include, you can just choose the total value as your response variable, right? The advantage for the decision tree is it doesn't matter you have the quantitative predictors or you have the categorical predictors. It doesn't matter what type of variable you have. You can always include all of them. Right, from the lot square fit until the remodel, all of these predictors to the X. Right. If it is a categorical variable, the jump can defaultly generate the dummy variables, and then you don't need to care about anything. You don't need to deal with the categorical variable by yourself. What you need to do is just add these variables into the X space, all right, and then click OK. All right, so the default is exactly the same. Now let's split. Right, so that means the first split is based on the living area, right? Okay, and then let's keep splitting, keep splitting. Let's see, let's look at this R square, right? So it will, every time you have one more split, the R square will keep increase. That means your prediction will be more and more accurate, right? So let's say I want to make an accurate prediction. I want to split, let's say 20 times.
Can I ask a question really quick?
Sure,
How many times do you split? Like when do you know when to stop?
good question. We'll talk about this in 2 minutes.
Okay, awesome. Thank you.
All right, good question. All right, so let's say for this time we split 20 times, right? So that means we'll have this big decision tree, right? So actually, even this whole screen cannot hold the whole decision tree. All right, and then let's say go to the options and then choose the column contributions, right, and see what happens. All right, so here, this is the column contribution table, right? So from this table, what you can find, it looks like even though I split 20 times, some variables are even not used at all. They contribute nothing to the prediction or the estimation, right? So actually 7 of them are because of the living area. Some of them are because of the lot square feet, square feet, right? And then 3 of the splits because of the gross area. But from the year of build and until the end, actually they are not used at all. So that means these variables are not very useful for predictions, right? So actually this column contribution can be very, very useful even if you don't want to create this decision tree, even if you want to make the regression. For example, in the in your project 2, you want to generate the equation, but if you have this column contributions, you know which variable is more important. Right? So actually in this case, the living area contributes 92.19% to the prediction or to this decision tree. Of course, this living area should be included in your regression. All right. And then once we get this, it brings to a question, right? So actually, good question. How many splits or when do I need to stop my splitting, right? You say, okay, I want to split for 5 times. I want to split for 20 times. And then if you want to get a more accurate result, you can split for 30 times. Then how or when can I stop, right? So good question. We can just close that. All right. And then here, let's come back to our note. We say when we talked about the regression, right? We talked about this set, right? So one is the training set, one is the validation set. We say whenever we have the sample, we want to divide it into 2 sets. The training sets, we want to generate the model. Validation set is to validate whether our model is good or not. Right? And then in the decision tree, we just want to use this validation set to determine when to stop. All right, so now let's come back to our data set, right? So I will talk about later about how to generate this column, right? But now assume you have this column, you have this variable now, right? So it is called the validation column. All right, and then let's go to analyze, predictive modeling, partition, right? So everything will be the same. The total value will be the y, right? And large square fit until the remodel, right? All of these predictors goes to x. But now you have one more step to do, which is pull this variable, pull this actor column, which is the validation, goes to the space of the validation. All right, so now click OK. You will have a very similar output, right? Default output, but the difference is you have one more button, which is called Go. All right, and then in the summary table, you have 2 rows now. One is for the training, one is for the validation. All right, so now let's click the Go, this button. All right, so in default, the decision tree is not shown, but you can see that the number of splits is actually 91. So that means you need 91 splits to get the most accurate prediction. So what does that mean? How they decide 91? Right? It is because of this split history. Right, so let's look at this split history plot. Right, so in this plot you have 2 curves. Right, so actually the first one, the blue curve, is for the training set. Right, and the red curve is for the validation set. We say for the training set, when you generate the model, if you have more and more splits, of course the R square will be increasing. Right, in the end you will see that the blue curve is keep increasing, even though after this point it's also increased, right? But For the validation set, the R square will also keep increasing until the 91 place. After 91 place, the R square will decrease. That will be not increasing anymore. So that means this part until 91 place, you have the most accurate prediction. All right, okay, so then we say once you add the validation set into our decision tree process, right, the validation set can decide when to stop. Right, so in this case, you need to split 91 times to get the most accurate predictions. Right, so now what if I want to look at the decision tree? Here, not showing you any decision tree, right? So remember, go to the red triangle, right? And then display options. Right here, show tree, right? Check that. You will have the whole decision tree. Right, so but in this case the decision tree is too large, right? So then in this case, in most of the time we want to save it as a PNG file, which is as a picture. All right, and then what should I do? Wait a second, be slow. Okay, and then we say once we have our output, right? We first will have four outputs, right? The first one will be your summary table. Right, so this summary table will tell you the R square for the training set and for the validation set, right? And then the MSE, right? And the number of observations in the training set and the observations in the validation set. How many observations in the training set? How many observations in the validation set? How many splits do we need? All right, okay, and then we say we go to the red triangle. Remember, for every decision tree, we want to include the information for the column contributions. Right, so once we have the column contributions, we see that, okay, now we have the validation set, and then these variables will contribute to the prediction. Only the kitchen didn't contribute anything to the model, to the decision tree. Right, so now I want to save it. Right, if you have the Windows, then you can go to just a file and then save as, right? And then you can save the decision tree not as the jump report, right? So it will only work in your own computer. So save it as the PNG file, as a picture. All right, and then you can save it. Some of you cannot save it like if you have the MacBook, right? Then you click the file, there should be one option for the export. You see that? Export, right? And then you should be able to see the image, right? And then next, you can also save it as this file, right? PNG file, which is the picture, right? Any other questions for saving the results? Good. All right. Okay. So now, we talked about the example, right? So we say, let's look back to our file for this practice, right? So we have already talked about that. We talked about adding the validation into our validation part, right? And then we can get our split history and then this summary statistics, right? Summary table, right? And then based on that, we can answer these questions, right? So first, how many splits are truly necessary? How many? 91, right? So how many observations in the training set? How we can find that? Would be the N for the training set, right? So would be what? Would be 2848, right? How many observations in the validation set? Would be here, right? 2954. Right. Next, which variable is considered to be the most effective? Which variable? Agi.
Can you ask that again? I was looking through I was trying to figure out how to save it.
Sure. Which variable is considered to be the most effective? Where you
Yeah,
can
yeah,
find
I'm
it.
thinking it's living area. It's under column contributions.
Right. So actually we need to look at the contributions, right? So then which one is the most effective will be the living area, right? It takes 82.74% of the contribution, right? Okay, nice. All right, so now we kind of done with the decision tree, but remember, we say the decision tree can deal with the continuous random variable or the response variable, or we say the quantitative response variable. And the decision tree can also deal with the binary, or we call the categorical decision tree. Right, so then we say we have two kinds of decision trees. Right, the first kind is if your response variable is a quantitative random variable. Right, then the inside of the decision tree is based on their regression. Right, then we call it is the regression tree. Right, another kind for the decision tree, if the response is qualitative, that means if your response variable is a categorical variable, then we can generate a classification tree. All right, so now let's look at our example here. Still with the same data set, but based on this total value, this response variable, I create another response variable with a binary response, just a 0 or 1, yes or no. All right, so that means if the house value, the total value is less than 500, right, then this variable will be recorded as 0 because it is not larger than 500. The other way, for example, this one, right, that means what? That means the total value this observation. All right, the total value for this house is 575. That is larger than 500. Then I just record it as 1. All right, so then in this case, if this variable is my response variable, that means this variable will be a categorical variable with either yes or no, larger than 500 or not larger than 500. Right. Then if my response variable is a binary response variable, then we can also create a decision tree to make the predictions, even though I do not have our detailed information for the house price. All right, so then we can generate we call the classification tree. Right, so analyze, predictive modeling, right, again, partition, right? Everything will be the same, right? Instead of using the total value as our response variable, we want to use this categorical variable, value larger than 500, as my response variable, right? And then all other variables again as the predictors. Remember, we want to use the jump to stop us when we have the most accurate predictions, right? So then we just use the validation, goes to the validation. All right, and then click OK. All right, so now this is the default output, right? We see some colorful things instead of just the black words, right? So actually we have the red color and blue color. So what does that mean? We say here we totally have 2,848. So that will be the total counts. All right, and then if I ask the jump to show the detailed counts for larger than 500 or less equals to 500, right? Then I can ask the jump to display the options to show the counts, right? And also show me, let's say, show me the probabilities. Yes. So at the same time, show us the or proportions, right? So after you choose that option, it will tell you how many of them are zeros, how many of them are ones, right? How many of them are having the house price which is less than 500? How many of them is larger than 500? All right, so this is the overall, the whole data set. Now, since we set the validation, right, then we just click go. Right, and then you will have this colorful decision tree, right? So actually the point is the same. We just divide them into two subgroups based on the first step, based on the living area. And then for this living area, it is divided into two more subgroups based on the living area again. And then next, it is divided into two subgroups again based on the gross area, and so on. All right, so based on the fair places, the number of bathrooms. All right, okay, and then we say now if your response variable is a categorical variable, it's a binary response variable, then you only need 9 splits. Because what? Because you don't have very much information about the response. Just the 0 and 1, right? So in this case, it is easy to split the whole data set. So actually, you only need 9 of them. All right, and then now we can again choose the column contributions to see which variables are contributing to our model or to our decision tree, right? So actually in this case, more variables are used, right? So actually these variables are not very useful, right? Just contributes nothing to our decision tree. All right, and then how we can make our predictions. Let's say for the first subgroup in this decision tree, right? So that means what? That means there are totally 9 of them are the house with the house price less than 500. There are 175 of them, or 174 of them, having the house price larger than $500,000, right? So that means in this group, kind of pure with the most expensive houses, right? And then in this case, in this subgroup, there is only 19 houses, right? This one will be 53 houses are expensive houses, right? And then let's say for the last one, right, the last subgroup, actually it shows all red. That means what? That means there is no expensive houses, right? All of them are the less expensive houses, right? So it covers totally 1,048 houses in this subgroup, and no one is the most important, most expensive house. All of them are less than 500, right? Okay, so then there anything else? So this is about the classification tree, right? So you need to show the 0 and 1s so that you know this subgroup contains how many houses, right? So if I'm looking for which group is the most, shows the most expensive houses, that will be this group, right? So this group will be the most expensive houses, right? With more than one fair places, the gross area is larger equals to 4322, and also the living area should be larger than 2352. And living area is larger than 2144. So actually this subgroup will be showing you the most expensive houses. Right? Okay, so since your response variable is binary, that means when you make the prediction, you can only say, okay, your house is above $500,000 or less than $500,000, right? So you don't have the mean because your response variable is just a binary. All right. Okay, so that will be about the classification tree. And then the last job for today will be talk about how to generate this validation set. All right, so let's just, let me just delete that. All right, suppose we do not have this validation set, how we can create this variable or how we can create this column. All right, so again, we can go to Analyze, Predictive Modeling. All right, and then below the partition, you will see one option for Make Validation Column. You see that, everyone? Got it? So it will be Analyze, Predictive Modeling, and then there will be one option for Make Validation Column. Right, okay, got it. Right, and then the default here say optional, optional here, optional all of these. So actually these are the actual requirements for setting the validation set, right? So we do not have any actual requirements. So then just click OK. And then here is the place that you set the proportion of your validation set, right? So for example, the default is 0.75. Then for example, I can set the training set as 0.80. Then at the same time, the validation set you need to set as 0.20 to make sure the sum of these two sets is 1, right? And then click Go. Then this validation, this column will be generated, right? So they are randomly chosen to be assigned into training or the validation set. All right, and another way to generate or use the validation set is when you just, if you do not have this validation set, right, then you predictive modeling and then partition. All right, and then if you want to generate the decision tree and you also need the validation set, right, then here there is an option for you to set the validation portion. So here you can set, for example, 0.2. That means 20% of the whole sample will be used as the validation portion. All right, and then everything will be the same, total value until the end will be the X, all right, since we do not have this column, right, we just set is 0.2 here, right, and then just click OK. You still have this option, go. Right, so even though you didn't use this validation column when you generate the decision tree, as long as you set the portion of the validation, then you will have this result. But the point is, this validation set is randomly chosen. That means if you repeat the same process, for example, analyze, partition, right? You still use the total value. You still use all of these variables. You still set the validation portion as 0.2 and then click OK and then go. All right. And you will find that even if you follow exactly the same process, the results will not be exactly the same. You see that? One of them is 25 splits, the other one needs 48 splits, right? So actually, that's because what? That's because every time you use the option for the decision tree for the validation set, they just randomly choose the observations from the data set, and then every time they just randomly choose ones, and you every time you use different data sets, right? So then you will not have any consistent results. So what I recommend will be generate this validation column first so that everyone will consider the same, using the same data sets, you will have consistent results for everyone. All right. Okay. Any questions? Good. All right. And then the next half hour, I will just give you time to complete your data analysis 3. Right, so I thought 30 minutes is enough to complete the data analysis 3, but actually for the previous 2 sessions, actually it is not that case. So I just make it, you can complete it for multiple attempts, right? In the end, I just extend your due date until this Sunday, right? So you have quite a lot of time to complete it, but I still ask you to complete it in class, right? Because you may have different kinds of questions for this data analysis, and this data analysis is for not for teamwork, right? You need to complete by yourselves. So for this data analysis 3, actually we have already talked about this data set in the last class, right? So we say it is about the organics, right? So we say for this supermarket, right, we just collect all of these informations, right? The first one, ID, we say the ID should not be included, right? So actually we say the ID is just a identification, right? So it should not be included in our analysis, right? Another thing is about these two, right? We say these two variables have the repeated information, right? So then we need to delete one of them. So whenever you have the data sets, you will have a model row that describes that what are they, right? So actually ID, actually it is not an input variable for us, right? So actually this should not be analyzed by our decision tree, right? Another thing is this variable, right? The DEM cluster is rejected. That means this one should not be included in our analysis neither, right? And then you have 2 target response variable, which is they are both response variables, right? The first one is a binary response variable. The other one is the continuous random variable, right? So that means you can generate first the regression tree for this continuous random variable. You can also create another tree which is for classification tree, right? So either you have yes or no, that means you have categorical response variable. All right, okay, and then you just follow the instructions and download this data set, right? And then answer these questions. So that means before you answer these questions, once you got the data sets, you always need to exclude the ID, exclude the DAM cluster from your data set so that you do not need to worry about these two variables. Right, so just let me know if you have any questions. If you have any personal question, you can just type in the chat.